Bismillahirrahmanirrahim. Hello everyone, welcome back to the PL-300 exam preparation series where we are talking about the second learning path, model the data. In this video, we are going to discuss the topic improve performance by summarizing data, which is part of the section optimize model performance. We have slightly touched upon this topic in one of the previous videos, and that was also related to model performance and how you can reduce the size of the data model. So we are going to explore this concept in more detail here. So we are also going to talk about another concept that we have touched upon, and that is related to how we can do the aggregations. And another concept that we are going to touch upon, which we haven't discussed in any of the previous videos, is normalization and denormalization. So people who are familiar with database design and who have done data warehousing, they are very much familiar with the concept of normalization and denormalization. But I'm going to just summarize it for people who are not aware of this. So do watch this video very carefully, because this is a very important video in terms of some of the questions that you can get on the PL-300 exam. So perhaps the most effective technique to reduce a model size in Power BI is to load pre-summarized data. So remember, we had a detailed look at the group by functionality where we saw that how we can reduce the size of the table by using the group by functionality, and this is the same functionality or a similar concept that we are going to discuss here. This technique can be used to reduce the grain of the fact type tables. So here a new terminology has come, which is the grain of the fact table. So what is the grain of a fact table? So remember that most of the data in a fact table is transactional. So most of the data that you're going to find inside a fact table will be either related to a date or maybe to a date and time as well. So once we are saying that we are going to raise the grain of the fact table, so that means that we are going to change the level of detail. So wherever you find the word grain or granularity, it means that we are talking about the level of detail. So let's try to understand this concept of granularity and level of detail through an example. So for example, we have a source fact table, sales fact table, and it stores one row per order line. Significant data reduction could be achieved by grouping by date at a month level. It could achieve a month possible 99% reduction in model size, but reporting at day level or individual order level is no longer possible. So let's take an example of a sales table. So we have looked at a sales or a transaction table in both the examples that we did for Maven Market and for Superstores. And you remember that the transaction table is associated with every transaction. So that transaction can be captured at a day level. It can even be captured at every second or every minute that that transaction takes place. But let's say that once you are doing the reporting, you are not interested in capturing the level of detail at the day level. You are only interested in capturing the detail at the month level. So the goal of showing the results is that how much each product was sold at a month level. So if you have such a requirement, then there is no need to actually save the data at a date level or day level or even at an order line level. All you can do is that you can use the group by functionality and you can reduce the size of your table by grouping or summarizing everything at the month level. So imagine putting all of the transactions taking place in a month in just one field. So it can reduce the size of the data model by up to 99%. But this is a very important aspect that you have to actually first look at the reporting requirements. If the reporting requirement says that you have to actually look at the individual order level or at the day level, then obviously you cannot reduce the granularity to the month level. But if there is a scenario where you do not need to store the data at the date level or at the individual order level, then it makes sense to go and save the data at a granularity which is the minimum requirement for reporting. So you cannot go from a month level to a day level, but obviously you can go from a date level to a month level, and you can reduce the granularity. So this is a trade-off that you have to do, but this is very effective in terms of reducing the model size, because it reduces the model size by a lot of a lot of factor. I would say that maybe you can achieve 100x reduction in the model size, but just keep in mind that there is a distinct trade-off, and this can result in the loss of detail, and this can also have an effect on the end reporting that you are trying to do. So, like I said, that deciding to summarize the fact table data always involves trade-off. But there is another technique which is available inside of Power BI, which is called as aggregation. So by default, this scheme is only available for fact table, which is in the direct query mode. So only the tables, the fact tables which have the table storage mode set to direct query can use this technique, but you can otherwise use this technique based on your own experience, even for the import type data models. But then you have to take care of a lot of other things as well. Although aggregations is not a topic for the PL-300 exam, this topic has been moved to the DP-500 exam, but I am just going to spend a couple of minutes talking about aggregations, and then we are going to go and see how these aggregations are applied in the Power BI environment. So, like I said, that we have aggregations only available for the direct query data sets, and the concept of aggregation is based on caching aggregated level data in memory. So what you have is a fact table that is there in the direct query mode, and you create new aggregated tables based on any categorical columns, and those columns are available in the fact table. But the aggregations that you do and the tables which are created based on those aggregations are stored in the data model in the import mode. So what happens is that if there is a query that requires you to address a particular question, then if that query can be answered through the aggregated table which is in the import mode, then the query is actually returned through the import mode. So that actually improves the performance, because the aggregated table is very short. It is not taking a lot of memory. And if the query cannot be answered through the aggregated table, then the query goes and hits the actual fact table which is in the direct query mode. So this is how aggregations work in Power BI. So this is one consideration that you should be aware of, that this functionality only works for direct query, and you have to manually configure this in the data model. However, for the premium licenses, this can also be done automatically inside of Power BI. Another way of achieving the same aggregation thing is through the use of materialized views. So people who are aware of views or materialized views in a database, they know that how these views are created, and these are available in databases. So you can also achieve the same functionality by creating materialized views and using them in direct query or within the Power BI. Then aggregated table is created and can be used in the import mode. Another important concept that I mentioned at the start of the video is related to normalization and denormalization. So people who have worked in the databases, they know what is normalization and denormalization, but it is important to understand how normalization and denormalization works in terms of the data model. So in order to understand all of these things, let's go to the Power Query Editor, where we are going to have a look at aggregations, and then I'm going to talk about normalization and denormalization. So here I am inside the Power Query Editor, and what I have done is that I have connected to my AdventureWorks DW 2019 database, which is on my SQL Server instance on my laptop, like the one you should have on your machine. And what I have done here is that I have connected to the database, and I have brought in four tables in direct query mode. So the first one is dim customer, the second one is dim date, the third one is dim product, and the fourth one is fact internet sales. There is another table that you are seeing here, and this table has been named as product sales aggregate. What I have done is that I have created a copy of the fact internet sales via duplicate, and I have created this product sales AGG or aggregate where I have done aggregations based on product key. So what I have done? So I have done here is that I have just gone into this table, the fact internet sales table, selected the product key, and then I have done the group by based on the product key, and I have done the group by on a column which is here, and that column is the sales amount column. So this is the column, this is the sales amount column. So what it has done is that it has given me the product key wise total sales amount. So I have tried to capture, or I have tried to summarize the information present in the fact internet sales table in another table which I am calling as the product sales aggregate, where I have just reduced the size of the table from maybe I don't know what was the size of the fact internet sales table in terms of the number of rows, but we can just have a look at this. So I just need to go and select the column distribution. So here I would know that how many records are there. So here, based on the column profile, I can see that there are 60,398 records which are present here. So I have used the product key column, and by using the group by functionality, all I have done is that I have reduced the size of those 60,000 transactions down to just 158 records. And obviously, because the group by reduces the size of the table in terms of the rows, and now there is just one product key per row, so it has aggregated the total sales based on the records, and now I have just 158 records in this particular table. So this is what I have done in the Power Query editor, and now I am going to just press close and apply and go inside the Power BI data model view and see how we can actually use these aggregations. So here you can see that I have created the data model. I have tried to skip some of the steps so that you should also practice this on your own. So what I have done is that I have created this data model, and here I am treating this product sales aggregate table similar to how I am dealing my fact internet sales table. So here it has a relationship between the product key from the dimension table, and also obviously there is just one dimension, so the other column here is just the total sales column. So I am treating this product sales aggregate table as another fact table. Process of creating aggregations, actually, like I explained in once I was talking on the slide deck, is that you actually try to solve the queries and you want to bring in the data in an aggregated form directly from a table which is set into import mode. So currently all of these tables are in the direct query mode, and what we are going to achieve from this kind of a hierarchy or this kind of a model is that once there is a query that is just requiring that what is the sales by the product key, then that particular query will be answered through this particular table. But if we are looking at more details, like we are talking about product key, or we are talking about a customer, or we are talking about more detail where we are even looking at the detail in the transaction table, then the query is going to be answered from this table. But remember, this table is going to be in the direct query mode, and now I am going to convert this table from direct query into import. And similarly, remember that we talked about the composite models. So once we convert this into an import mode table, it would become a composite model. And for the composite model, the best practice is that you also convert the dimensions into dual storage mode. So now I am going to convert these three tables into dual storage mode and this table into the import mode, and then I am going to show you how we actually manage the aggregations. So I have converted the table storage mode of these tables to dual, the three dimensions to dual, and the product sales aggregate to import. And here you can see that the dual tables have this slightly different blue mark, which has a few white spaces, and then there is a blue mark. So this is another indication that if you see such a table, that then you should know that this is a table which is in the dual mode. So now just the last step is left, and that is that we need to tell the Power BI data model that okay, this is an aggregated table and you are going to answer the queries based on the aggregation. So this is done by selecting this product sales aggregate table, and I'm going to press right click, and then there is this option which says manage aggregations. Remember, I said that although this topic is not a part of the PL-300 syllabus, just remember that you should be aware of this process. Maybe you get some kind of a question which is somehow related to the concept, not the aggregation itself. So here the focus of my interest is this total sales column, because here this column has the aggregated values, the aggregation that has been applied, the aggregation function of sum that has been applied on this column. So here we are just going to specify what we have already done. So here I'm going to go and click on the summarization part, and I know that the summarization has been done on the sum. Then I'm going to select the detail table. So what is the detail table? So if a query is not resolved by the product key and total sales, and it has some kind of an other column which is required, then this table is of no use. But you have to tell Power BI that okay, if this is the scenario, then you will have to go and answer the query based on the fact internet sales table. So this is the table which is going to be queried if the query is if the background query requires more detail, which is not being answered through these two columns. Then go and select the fact internet sales table. And lastly, the total sales column inside the fact internet sales table has been created based on the sales amount column. So we actually perform the same aggregation on the sales amount column in the fact internet sales table to build this total sales table. So this is how you define the aggregations on the product sale aggregation table. And now I'm going to click on apply all, and after a few seconds you are going to see that the window is closed. But one thing that you must have noticed, and I can see here as well, that once you have defined the aggregations, then this table is a hidden table. So the end user cannot interact with this table. Behind the scenes, Power BI knows that if the query is can be answered through this table, then this is my first preference, because this is an import mode and this is a shorter table or a smaller table, and the result will be returned very quickly. But if the query cannot be resolved from this table, then I have to go and I have to solve or resolve the query through the fact internet sales table. So this is how the aggregations work inside the Power BI environment. Just remember that this table has to be in the import mode. This table, the fact table, has to be in the direct query mode. And the recommendation is that you should have the dimensions in the composite model set to the dual storage mode. And this is the way you are going to get the best performance out of our data model. So the last concept that we are going to discuss in this video is the concept of normalization and denormalizations, which is primarily a concept that people working in databases are familiar with. So I'm going to go back into the superstore file where we had spent a lot of time once we were building some of the videos. We were doing some of the videos in the previous learning path, and we built this superstore data model. And you can see this data model here in this particular window. And we had built the dimensions, and then we had built the fact table. So here I'm just going to look at the fact table here, which is the transactions fact table. So I'm just going to go into the data view or the table view. So here you can see, I can see all the different columns which are available inside the transactions table. Here I am going to just focus my attention on two columns. The first column is the order priority and the other column is the ship mode column. So both of these columns are available here. So as you can see that the total size of this transactions table is 9426, which means that there are 9426 records. So I can see here, let me just focus now on just one of these columns, which is the ship mode column. So now you can see that for all these 9000 plus records, I am seeing a value of a shipping mode, and this value is a text value, right? So all the other columns other than the order priority column, obviously, all of those columns are columns which have an integer value in the column, and most likely the data type associated with these columns is also an integer data type. So remember, we looked at the importance of data type in one of the previous videos, and I said that if you have a table where you have integer data types, then the kind of encoding that is being done in the background by Power BI storage engine is more efficient than the encoding which is done on text tables. So we can clearly see that this ship mode column here is obviously has text values. So all the values here would be requiring hash encoding, which is not as efficient as the value encoding. Also, we see another thing that the same text value is being repeated in most of the records. So there might be a few other shipping modes, I'm not sure, but we can just we are going to have a look at it in a bit. But just see that how the values are being repeated here. So this is again something which is related to the model efficiency. So here comes the concept of normalization and denormalization. So what we can do is that instead of having this shipping mode here as a column, I can take this shipping mode column out of here. I can create a new table, which would be a new dimension, and I am going to put the shipping mode, whatever shipping modes are there in the dimension table. Obviously these have to be as per the definition of the dimension, that I need to have one record per row which has to be unique. So I am going to create another table which I am going to call as ship mode table, or whatever name I want to give it. And then instead of this ship mode column here, I am going to replace it with an ID column, which is going to be present in the ship mode dimension. And that is going to do is that this text column will be replaced by a column which is no longer text, and it has just the numbers, and which is the ID column. So then if the compression algorithm works on this table, then it would be much more efficient. So the process of creating this new table in a data model, where I am going to pick one column in my fact table and creating another dimension table and then building a relationship, this process is called as the normalization process. So what we are saying is that we are breaking our fact table into more dimensions, and we are normalizing the data. And the reverse process, where you actually combine the different tables, is called as the denormalization process. So this is something that you should remember, because this is a very important concept. Now let me just quickly go and quickly create this dimension in Power Query Editor. So here I am back inside the Power Query Editor in for the Superstore file, and I'm going to create another dimension which I'm going to call as storage mode. And I can create that particular dimension by following the same process that I've followed for all the other tables. So I'm going to just use the Superstore raw query in the staging layer, and I'm going to create a copy using reference. I'm going to drag this copy here in the data model, inside the data model, and then I am going to change the name of this to ship mode. So in this table, I just need to keep the ship mode and I do not need anything else. So I'm just going to select the ship mode column here. I'm going to remove all the other columns. Then I'm going to again click here and then I'm going to remove the duplicate. So I just have three shipping modes. So I can just create a column, the ID column, which I can just go and click on add column, and then in index column I'm going to select from one, and I am going to rename this column as ship mode ID. So now I have this new dimension created. Now I am just going to create a merge operation using this ship mode column between the ship mode dimension and the transactions fact, and I am going to replace the ship mode column by the ship mode ID. So let's do that. So here I'm inside the transactions table. I'm going to use this merge queries functionality, and I'm going to say merge queries, and here I'm going to now select my new table ship mode, and now I need to just select the ship mode column on both sides, and then I'm going to say okay, do the merging. We have already done this, so I'm just trying to do this very quickly in one of the previous videos. So now here I can do take advantage of this expander, and I am just going to click here on ship mode ID, and now the ship mode ID is available inside the transactions table, and now I can go and I can delete this ship mode column from this particular table. So I'm just going to click here on remove, and the ship mode column here has been removed. Now I'm just going to click on close and apply. So now I am inside the Power BI desktop environment again, inside the model view, and here I have created this relationship between ship mode ID and ship mode ID. So this process of breaking the transaction table and creating a new dimension, which is this ship mode, this process is called as the normalization. So the reverse process where you combine tables and you reduce the number of tables, that is called as the denormalization. So this is also a very important aspect in terms of the performance improvement. So you always try to keep the fact table in a way that all the columns in the fact table represent a numeric data type, and you can create new dimensions. We are happy with this new dimension because we know that this is still following a star schema, and Power BI is happy to actually deal with the star schema. So this was a very long video, but this was very necessary because we were talking about a very important topic, which is the summarizing of data. So we also looked at aggregations, and we also looked at normalization and denormalization. I'm also going to put two links which are from another YouTube channel, from a YouTube channel, where some of the best practices for data modeling and also for some of the things that we did while we were doing the work in Power Query Editor. I'm going to point a link to those two videos. So if you get time, just watch those two videos because they are going to be helpful in your preparation. So that's all for this video, and I will catch up with you in the next one.